All right, let's talk a little bit about the antagonistic hormones of the endocrine pancreas, those hormones that have opposing roles with regard to plasma glucose. I'm talking about the peptide hormones insulin and glucagon. Most people are familiar with insulin. Fewer people really understand the role of glucagon. Again, these are antagonistic hormones because of their opposing actions on a regulated variable that is plasma glucose. And as we'll see, these hormones actually have an effect on more than just blood glucose, but other metabolites as well. Let's start with insulin. This peptide hormone is a product of pancreatic beta cells and is released by these beta cells when the pancreas senses increased plasma glucose concentrations. Plasma glucose concentrations above set point. So what are the actions of insulin? Well, generally speaking, insulin acts to lower plasma glucose. It does this by promoting glucose uptake in most cells. A notable exception are cells of the nervous system. Neurons, including those in your brain, do not require insulin for glucose uptake. Most other cells in the body are either aided by or require insulin for glucose uptake. So, this insulin-mediated increase in glucose uptake by cells lowers plasma glucose. Not only does it increase glucose uptake, but insulin also stimulates the production of glycogen, storage form of glucose in the liver and skeletal muscle to a lesser extent. But it's the liver glycogen that the body utilizes in between meals for a circulating source of glucose. Insulin also stimulates the uptake of fatty acids and glucose into adipocytes, fat cells. This allows for these cells to promote the synthesis of triglyceride, or fats, within these cells. Lastly, insulin is also stimulatory to the uptake of amino acids by many cell types, promoting protein synthesis. So more than just promoting glucose uptake, insulin really is a pro-growth hormone through all of its actions. Glucagon, on the other hand, is an antagonistic hormone to insulin. Glucagon is a product of pancreatic alpha cells. And glucagon is released when plasma glucose levels fall below set point. Now, what are the actions of glucagon? Generally speaking, the actions of glucagon are opposite to those of insulin. That is, glucagon prevents glucose uptake by most cells. Glucagon promotes the breakdown of glycogen in the liver, glycogenolysis. Thus, the liver secretes glucose back into the bloodstream under the control of glucagon. Glucagon also promotes lipolysis, or the breakdown of triglycerides in adipocytes, releasing glycerol and free fatty acid into the bloodstream. Lastly, and especially if glucagon levels stay elevated for a significant amount of time, glucagon can promote proteolysis, or the breakdown of proteins, thus increasing amino acid into the bloodstream. So glucagon acts to elevate blood concentrations of these metabolites, whereas insulin acts to lower it. All right. Now, let's talk about glucagon's actions again, and the fact that it's aided in its actions by at least 3 other hormones. That is, glucagon acts to elevate circulating concentrations of metabolites, glucose, free fatty acids, glycerol, and amino acids. Glucagon gets help from epinephrine, gets help from growth hormone, and these are extremely important in aiding the actions of glucagon. And importantly, don't forget, glucagon also gets help from the steroid hormone cortisol. Cortisol, especially sustained levels of cortisol, will increase plasma glucose concentrations, glycerol, free fatty acids, and amino acids. So all those hormones act together to maintain circulating levels of these necessary metabolites. Insulin, on the other hand, acts all by itself. There is no other hormone that can directly lower plasma glucose. that can directly lower circulating concentrations of amino acids, free fatty acids, and glycerol. And thus, when there's a problem in insulin production or in insulin's actions, there can be some significant problems for many cell types in the body. This leads us to discussion about diabetes mellitus. What is it, first of all? Well, diabetes mellitus is a sustained elevation in plasma glucose. Sustained elevation. Prolonged high blood glucose levels, or hyperglycemia. And by hyperglycemia, we mean a level of blood glucose that's above set point. Now, one might think, well, so what? You got elevated blood glucose concentrations. Why is that such a bad thing? The problem is the elevated blood glucose really is a symptom of the fact that cells aren't getting the nutrients they need. That is, the elevation in blood glucose is due to either a lack of insulin production, that's type 1 diabetes, or a lack of insulin's actions, type 2 diabetes. Type 1. An individual fails to produce insulin by pancreatic beta cells. Now, we're not really sure why this happens. Evidence points to a virus that attacks the body, there's an immune response to that virus, then the antibodies start attacking the pancreatic beta cells, ultimately leading to pancreatic beta cell failure. Type 1, individuals with type 1 diabetes mellitus do not produce insulin, thus they need an outside source of insulin. Now, if they get that outside source, they manage their condition well, everything's just perfectly fine. It's can be a little bit tricky sometimes managing the proper amount of insulin, especially around meal times. Individuals with type 2 diabetes mellitus are non-insulin dependent. They have a form of resistance because these individuals make the hormone insulin, yet their target cells fail to respond to the hormone. How does this develop? We're not exactly sure, but we do know there's a link between diet, body fat mass, especially weight, as well as some kind of genetic predispositions. So individuals with type 2 diabetes mellitus are encouraged to go on a diet and exercise regimen to help them regulate this condition. Now, sometimes individuals with type 2 diabetes actually end up requiring an outside source of insulin. They have to be administered insulin because their cells become so resistant to the effects of insulin, it takes a very, very large concentration of insulin to get any kind of effect at all. All right. Again, if that's managed, type 2, no issues for the individual. The possibilities that I talk about with a lack of insulin or insulin effect in the voiceover slides refers to an individual who's not managing their condition well. Elevated blood glucose and sustained elevated blood glucose is the number one hallmark of either type 1 or type 2 diabetes mellitus. Again, why is that an issue? Really what it points to, again, is the fact that the cells are starving. They're not getting the glucose they need to carry out their metabolism. On top of that, that elevation in blood glucose can have all sorts of interesting effects. One effect is called glycosylation, where big sugar residues collect on proteins. These proteins are ion channels, these proteins are enzymes, and especially in neurons are really sensitive to this glycosylation. This makes these cells not function well. And so these individuals develop neuropathies. They develop poor circulation with endothelial dysfunction because of this. There's a whole host of problems that go with the glycosylation. Now, these individuals also may be subject to dehydration. And I'm not just talking being a little bit thirsty or a little bit of reduction in blood volume, but a significant dehydration. Because the glucose levels get so high in their plasma that the filtered glucose load into the proximal tubule exceeds the transport maximum. That is, all the carriers for glucose in the proximal tubule are occupied, and glucose makes its way past the proximal tubule into the Lupus-Henle distal tubule collecting duct. No carriers in those regions of the nephron. Water stays with that solute, and thus these individuals have a very high urine flow rate, an osmotic diuresis. And this is how they become subject to dehydration with prolonged high urine volumes. Lastly, I guess with regard to diabetes and poorly managed diabetes, these individuals may get into a kind of an interesting metabolic state. We already know, unmanaged, that these cells are starving for a lack of glucose. These cells may turn to metabolizing free fatty acids. This leads to the production of things we call ketones and ketone bodies, which acidify the body and can create all sorts of problems. These individuals are shifted into a different type of metabolic profile. Remember, with a lack of insulin or insulin effect, these individuals are basically shifted into a glucagon-dominated state. I guess I forgot to mention, or be more specific, back to the roles of insulin and glucagon. As antagonistic hormones, they kind of work in concert. Even though we think of them as antagonistic, they work together, really, to maintain circulating levels of necessary metabolites. In between meals, an individual is in a glucagon-dominated state. That is, glucagon has the major effect to maintain circulating metabolites. Immediately after a meal, an individual is in insulin-dominated state, where insulin is acting to promote storage of the ingested nutrients. So I hope this review video helps in some way. Let me know. Join the Zoom session. Send me an email. I'll talk to you later.